what we do.
What's in that balloon?
And Greg,
That's what I just asked.
let me
Oh.
interrupt.
I
Greg,
started
could you
it.
push the record button?
I started it.
Okay, great.
So like Holly Lynn said, we're all so excited to be here. Just to let you know a little bit about High Rise. High Rise is the hub for innovation and research and statistics education. And so we're a group at the Friday Institute at NC State, and we all are experienced at the K-12 and tertiary level in terms of teaching mathematics and education in general, but we all focus on statistics and data science. And so our group is composed of faculty, and Holly Lynn is a senior fellow at the Friday Institute, and we have research associates and research scholars and graduate students. All of our projects, there's lots of cross-institutional projects that we have going on right now. They all focus in some way on trying to prepare students to be data literate and to be better prepared to engage in data science, statistics, STEM careers. And so our focus often is on working in schools with teachers and students, but we also do a lot of online professional development for teachers as well. So you can go to our site. We've got lots of exciting projects. Hopefully we can reach out in some ways to support teachers, but we're all about doing what we can to support teachers to help better prepare students.
And we will have a handout later that will have links on it.
So just a quick overview of today's goals. We're going to start with just this idea of a data intensive approach. And then Holly Lynn is going to give us an overview of CODAP, and then we're going to engage you in actually using CODAP for a little bit. But to get us started, we all engage with so much data now, and our students engage with so much data from fitness trackers or during COVID-19, hearing about all the stats. And back in 2015, Oceans of Data said, we need a revolution in education, placing data literacy at its core, integrated through K-16. And so there have been a lot of calls since 2015 to create this idea of data literate citizenry. And we believe you can do this through a data intensive approach in the classroom. And some of the key components to a data intensive approach is engaging in real context, where kids collect data about themselves, or you collect data about a real idea or out in the world. We believe you need to use bigger data. Lots of our students only engage with data sets that are 10 to 20 cases, and we believe it needs to be bigger. Also, we need to have more attributes, both categorical and quantitative attributes. And then finally, we need to use technology tools to visualize this data and to analyze this data and to facilitate simple coding and data moves. But to do this, you also need to have a process for how you engage with this data, how you take a problem and you solve it using the data. And many statistics educators have proposed slightly different cycles, but they all are mostly the same. You might be familiar with the PPDAC or the PCAI, or the most recent version in GAZE 2 was formulate statistical investigative questions, then collect and consider the data, analyze the data, and interpret the results. We have taken the time, specifically Holly Lynn took the time to interview some data scientists, and then we have also looked through the data science literature to help expand on these cycles.
Can you figure out how to get me out of my phone, Zoom?
So we have come up with something we call the data investigation process, and it involves 6 phases. Can somebody maybe work on muting everybody else?
I'm muting them, no worries.
Thank you. So this cycle looks a lot like the statistics cycles, but we just include a few other things, or we unpack some of the statistics cycles in our 6 phases. The first phase starts with framing the problem. And this includes formulating a statistical investigative question, but it also includes looking at the broader context and understanding your problem. The next 2 phases are about gathering and considering your data, just broken into 2 different parts. One is consider and gather your data, where you're collecting it, figuring out what variables or attributes you need, thinking about how you'll collect that. Will it be data scraping? What kind of methodology do you need to maybe run an experiment to collect the data? Then once you get that data, how do you process it? How do you make it usable? How do you make it in a form where you can move on to that next phase, which is traditionally analyzed, but we've broken that, as you can see in these two bluish colors, greenish bluish. We broke analyze down to unpack it into two parts. One, explore and visualize the data. And the second part, after you've looked for trends and look for patterns, see what your data says, consider which models actually help you answer your question. And then finally, data scientists talk a lot about how part of their job is communication. And so we don't end just by finding an answer, we end by communicating that result out and knowing our audience and knowing how to communicate that result appropriately. So if you think about reviewing some of the things we just talked about, when you design, the design principles you need for data intensive tasks, first, you just need data that's real, multivariate, bigger, and sometimes messy. Data contexts that are engaging for students. You need tools that help you visualize and make links between the representations that you make and allow you to see graphical and tabular forms. And then your tasks just need to have multiple entry points and provoke curiosity and also provoke a need to work with that data investigation process, or at least parts of it. And today's presentation is going to really focus on these middle two, the tools. And now Holly Lynn is going to talk to us about how to use CodeApp. Ooh, are you?
You're on mute.
You're muted, Holly Lynn, I think.
Okay, so I think, Emily, I want to go ahead and share my screen. So
Yeah, I'm trying to unshare. I'm so sorry.
Thanks. All right, so I've got different screens on different monitors. So I'm navigating here. Okay, let me go into present mode. All right, can we see this? All right, so we're going to be focused on a tool called CodeApp, and if you look at your participant tab, which my tab has gone away, that is so weird. My participant tab has gone away. Holy cow. Okay, so if you are able to see the participant tab at the bottom, we wanted to do just a quick poll of checking yes or no if you have ever used either CodeApp or prior tools called Fathom or Tinkerplots. And if you
can raise your hand or put it in the chat.
Yep, so some have used Fathom, some CodeApp, some no's, neither of them. Yep. Yeah, and that's kind of what we expected. We expected about, you know, some of you are going to have used these tools before, and others of you are here so that you can actually learn a little bit about this tool. But one of the benefits of CodeApp is that it's free and it's browser-based. So there's no login necessary at all. No purchase necessary, no installment necessary. And it's super easy to use. And I'm going to hopefully try to demonstrate that today and give you some chance, give you an opportunity to actually play with some things yourself. And it's also under continued development. So since it's not deployed as a version 1.0 or version 2.0, about every month, they are actually releasing new features on CodeApp. It does work best on Chrome or Firefox. You know, it's not so optimal on a phone or a smaller iPad. So let me, excuse me. So at codapp.concord.org, and I can throw this into the chat. And again, you'll get this URL later. This is their website. And from here, you can just launch CodeApp by saying try CodeApp. All right, but I want to quickly just show you that if you click on the for educators, There's lots of available materials there. We don't have time to go through them, but we do have the links to these for you later. But if you just click on Try Code App and you can send your students here, it launches the application. They have some example documents that you can open, or you can just start and create your own document. So what we're going to do, I'm not going to show you, I'm not going to teach you much about the software until we're actually into looking at some data. So I'm going to back out of this and go back to here. And I don't know about you all, but I'm kind of tired of being at home, and my family is a big amusement park junkies. Mainly I'm an amusement park junkie, and I have made my family that. But I really miss kind of being out on coasters. So we've got a couple pictures of roller coasters here. And if you would just take a moment and you can put a response in the chat. What do you notice and what do you kind of think about when you see these different coasters? What are some things that you notice about them or that you start to wonder about? Height, curves, loops, different materials being used, different structures. Yeah, does it have a loop or not have a loop? Oh, one looks like a normal curve. High speed. Wow, what's the safety on those? What makes the roller coaster the best? Yeah, some are really long, some are, some are short. Yeah. That was our activity last semester, being on a roller coaster ride. Yeah, we're all ready to get off that, aren't we? Consistency of ride time, safety records, yes. Yeah, your heart rate, okay, so we start to kind of notice things about roller coasters, and we can start asking some questions. And there were actually some questions posted here in the chat. And so I have two questions here. One being kind of, are all roller coaster ride experiences the same? And we could probably answer that question without looking at any data, all right? Students can answer that question probably just by looking at pictures of roller coasters, which could be considered data. Images are certainly data, or just drawing upon their own experiences. But the second question, are newer roller coasters taller and faster than older coasters? We might have some intuition about it, but we're going to have a hard time actually supporting a claim to that kind of a question without some data. All right. So in our classroom, starting out by motivating an interest in a phenomena. So the phenomena that we're talking about here being roller coasters, showing them pictures, showing them videos of roller coasters, getting them to think about the different attributes that a roller coaster has is all part of thinking about if a case is a roller coaster, what are the characteristics of a roller coaster that we could actually measure and that we would show up as an attribute in a data set? Understanding the structure of a data set is really an important part of learning how to work with data. And you can't do that if you only ever work with univariate data or bivariate data. Your students have no opportunity to learn those kinds of ideas. So, but thinking about a phenomena and all the different things you could measure about that phenomena is a very natural way of thinking about, oh, if I have a case, then I can, there are different things that I could measure about that single case. So what we're going to do is we're going to open a code app file that we already have some roller coaster data in, and Greg or somebody is going to pop that code app link into the, oops, no, that's not what I wanted to do. I'm going to pop it into the chat there. So you can either watch me or you can play along. All right. And whatever your comfort level is. This is the tab that I wanted. Okay. So we have a document here where there's 3 different objects index already open, and we did this on purpose. When you usually open up a blank CodeApp document, all you have is your shelf and your different tools up here. But we already have a data set loaded, and that's usually the first kind of easy way to start learning a tool. Use an example where there's already data in it. So we have a data set in a table over here, and I'm going to talk about the structure of that table in a moment. We have a graph window already open that has a dot representing each of the cases. So I have a dot here selecting the wilderness run. And so then that case, it is a linked representation, is linked over in the table. But, you know, this really isn't a graph. It's just a window with a bunch of dots in it. All right. We would have to actively make it into a graphical representation. And if I opened up a document that didn't have a graph, I would just click on the graph icon up here on my toolbar. Okay. And then we have what's called a guide in CodeApp language, but it is a little HTML box here where we just have some information of where we got this data from, so that you have a sense of it is real, where does it come from, and what does it actually represent. So this data set is 635 coasters that are currently in operation in the United States that were built between 1915 and 2020. So if a coaster was built in 1937, but it's not currently in operation, it is not in this data set. All right, so this represents those that are only currently operating. And to get it out of the way, I'm going to go ahead and close it. And if I ever wanted to bring it back, I just hit my guide and choose my roller coaster information so I can get back to it. But I'm going to go ahead and minimize it because now that I know my data, I don't need to see it. So I have my table over here, and I can scroll over to see the different attributes that I have. And if I hover over a column label, an attribute name, it gives me a little definition. We had to put those definitions in. So that's part of, for a teacher, if you want your students to have quick access to definitions of variables, we actually had to put in that definition into our table. So, oh, I'm getting notifications. I should have turned those off. So if I wanted to graph something, you can see here, click here or drag an attribute here. So let's see, the question that I had posed before was what? Are newer roller coasters taller and faster than older coasters? Well, I have to think about which variables might help me investigate that question. Are they taller and faster? Well, let's see, I see something about max height here. So I'm gonna drag max height down here. So now I have a dot plot representing my max height. I got a lot of coasters that aren't very tall in this data set, but I have some, and you know that these are the ones that the kids go straight to. Like, look at that King da Ka. Has anybody ridden that roller coaster? That is really tall. All right. Once I have data in a graph, I have this side little toolbar menu that and under the ruler, I can start adding different things. So I could take a look at the mean, for example. And if I hover over the mean, the max height of all my the mean of the max height of all my coasters is 77. I'm not really sure that that's what that really tells me. But if I think about how max height might change over the years, I'm going to take years and actually recolor my data by years opened. So I made a move. I made a move here that is probably unlike moves you have used in typical kinds of software, where the dragging an attribute into the center allows you to kind of recolor things and see things in a different way. So my newer coasters, their height, some of those newer coasters aren't really actually very tall. So I don't know if newer coasters actually get taller. We had created an attribute called age group. So I'm going to drag that over. And I can see that a little bit differently. So here's my orange one. Those are my newest roller coasters. I'm also going to take that age group. And again, I'm just going to show you a couple different skills here because I'm going to turn you loose to play with some things. So I created a separated distribution. So now I can compare groups. All right. How many of you teach in Algebra 1 or maybe called Math 1 in your state, or a middle school class where you have to compare distributions and have students compare things with box plots? And I could take yet another variable. So one of the things that is really good about a tool like CodeApp is that very easily you can ask questions and wonder if another variable might be impacting what you're seeing. And you can add that variable in interesting ways to your graph to enhance that representation. And we have lots of evidence of working with students, both in middle school and high school, that they catch on to this incredibly quickly. And they make strong meaning of graphs that are way beyond what you would see in a typical textbook. I'm going to create very quickly a two categorical graphs. I'm sorry, a two-way table, just so that we can kind of see. So here's two categorical variables in my data set, whether it is made of steel or wood, and that came up in the chat before, the type of material, and whether it's classified as an extreme, a family, a kitty, or a thrill. Well, it would make sense to me that thrill would actually be reorganized. So I'm just going to drag that over to reorganize that graph. And stop. Yes. Okay. And I can add things like counts and percent. So what I can add to a graph and compute is changed because of the attributes and the variable types that I actually have. I do not know what that sound is. Honestly, it sounds like it's coming from my computer. My computer is making a very nasty fan sound. All right, I am going to stop sharing for a second. Is that, if I'm not sharing, does that sound go away? Somebody tell me.
Still there.
Oh, the sound went away.
Yes, it did.
It just needs
Okay,
to
I don't know where that sound was coming from.
Maybe somebody muted. Oh,
Oh, there it goes again.
I'm not sure what it is.
Huh. Okay, it's not coming from my computer. I have no.
So I can share my screen if we'd like.
This is wild.
This is wild, and I don't think everybody's muted, right?
Mute yourself, Holly Lynn.
Yeah, Hollywell, I think everybody else is muted.
This definitely sounds like a Zoom thing.
Okay. So we actually can't get the breakout rooms to be set up. I think they had to be set up before we started. So do we just want to do it as a whole group?
I think we could. I think we could actually One thing we could do is make sure everybody has the link to the file, and we could kind of separate by alphabet of work on Jamboard 1 if you are in a certain alphabet range. So I'm trying to look. We have about 50 participants here. How many Jamboard slides do we have set up?
We have 11.
Okay. All right. So we could do, why don't we set up approximately like, let me see if I can write this.
Emily, can you?
I am not host.
Yeah, I just sent something to you, Greg, because I thought you were the host. I'm not the
The
host.
problem is I tried to give the host back to Chris so she could set up the breakout room.
Okay.
Yeah, so we can't mute people right
We
now.
can't
Can't
mute
mute
people.
people. Please mute yourselves.
There are a few people that I went through, and there are a few people that are still unmuted.
All right. Okay.
Yeah, so while we wait, so I dropped the code app document into the chat. So if you guys can, go ahead and take a moment to get on code app and start exploring. And then below that, I put the Jamboard breakout room thing that we made. But honestly, if you guys just want to go and find a board and maybe post anything that you find in those Jamboards for everybody to see, that'd be awesome. So go figure out, just, drop some things on some axes, create some different displays, and maybe even put a little text document about what is it that you find. And even you can put a text document that talks about, like, does this match with standards in your state, or if it's standards, or if it's just like anything that you would use in class, either as like formative assessment or like a bell work or anything. So why don't you guys take and mute or something like that right now and take some time to play with the data and then post in our Jamboard anything fun that you find. And if you have questions, feel free to unmute and ask away. Or throw it in the chat.
So how do I get the highlighted dot that's blue to not be blue anymore? That drives me crazy, and I've done it a million times.
I think you can click outside the cases. Can you click outside? It may just stay there until you make a graph, honestly.
Move on.
I was just making another graph and it's still blue. I did it by accident, figured it out somehow once, but I can't remember.
Yeah, so I click on a dot and then I click the graph that's like, just click somewhere else in the graph and it goes away for me.
So you know where to find us. You can always Zoom us later and share your screen.
Right.
Is the issue
It worked.
being able?
It
Is the issue not being able to unselect a case?
Yeah.
Yeah, clicking anywhere in the document should unselect it.
Yeah, whatever Greg told me to do, that worked. So thank you.
So think about some of the things that you talked that you were interested in when you were first putting things in the chat about the roller coasters, and see if you can find attributes similar to the areas that you were interested in and explore a question. And then take a screenshot, grab a screenshot of your graph and put it on a Jamboard. I am going to share my screen again with the CodeApp file up. That way, if anybody has a technical question and I could demo a solution to that, I can do that.
Holly Lynn, I have a quick question. My mother-in-law called while you were changing things to box plots. Can you show me how you got those box plots again overlaid on top of the dot plots?
Absolutely. So here I have the data already separated. I'm going to back out just a couple. So here I just have a distribution of a continuous variable here. And I could add the box plot just for max height. And I did that through the ruler menu in the graph. And then if I wanted to separate that out, let's say this time I'm going to separate it by steel or wood to see if heights of steel or wood coasters are different. I can drag that. So if you already have a box plot on, it will separate it out into two. If you don't already have the box plot on, you can always add it once you've separated the data. Does that help, Lee? Nope, you're muted.
Yes, it does. I put my graph that I created on slide 3 in the Jamboard, and I think because of the type of graph I have, I can't change that to a box plot since I have it split in categories as well.
Oh,
Is
yes,
that correct?
you have it. Yeah, you have it binned. So you would have to unbin your max heights.
Okay. I liked the binning though.
Yes. No, the binning is useful. You just can't use a box plot at that point then.
Got it.
Because you're basically turning max height into a categorical. Yeah, and whoever just put in, somebody just dropped on slide 3. What is it? It's scale on the x-axis and I can't read that. Max height. If you'd add box plots then our box plots would just be vertical rather than horizontal. So you can use box plots either in the horizontal or the vertical orientation. I'll create one of those. I'm going to put steel and wood.
And real quick, for those that made a scatter plot, check out the movable line. If you click the ruler, there should be a movable line button that you can check out, and an LSRL button.
Yep. Thinking about those Algebra 1, Math 1 courses.
Mm-hmm. You could not only can you put in that movable line and then try to do some estimation here. You can add in squares with this many. Oops, that's not what I wanted. With this large of a data set, the squares are kind of messy.
I'm not sure who teaches AP statistics, but those squares, that's a great conceptual representation for kiddos so they can wrap their minds around what a least squares regression line looks like.
Yeah. And actually,
Definitely nice that it shows the sum of squares there.
yes, it is. And one of the videos that we're going to share with you, we're not going to watch it today, but we have a link to it on the handout, is actually me teaching Greg's AP statistics class using CodeApp and having them think about relationships and linear regression and residuals. And they show some really nice thinking in that video. So you can look at that later. Anybody have any other technical questions? I'm going to check out what's going on the Jamboards. Nice. I'm gonna do something to maybe blow your mind. Let me take off the movable line here and the least squares line. So I've got a scatter plot here, max height versus top speed. And I'm gonna take whether or not it's inverted. And I'm gonna put it actually on the right-hand side. So I'm gonna separate my data into whether or not the coasters are inverted or not. And so now I have two different, it separates my data into two separate scatter plots. So I have three variables going on here. And because I think that whether or not, oh, gave me a CodeApp error. Did not like something that I just did. All right, so sometimes errors happen and we will report this to the CodeApp team. For two different projects that we have out of the High Rise group, we actually work with Bill Finzer and his team at CodeApp and have actually designed some of the features that are in CodeApp. Box plot was one of our first ones that we designed 5 years ago at this point, I think 4 years ago, maybe. I'm going to reload this. Another thing I'm going to demonstrate for those of you that are still playing so this data is organized hierarchically. So we have one of the categorical variables called age group that we've pulled out to create the hierarchy, but I can pick up that variable and I'm going to move it back. And now I have a flat table. So most data, and there was a question earlier about, and I can see some things going on in the chat. CodeApp has some great help on how you can take a CSV file and drag in and make your and bring in your own data or enter your own data. And data is going to come in a flat table, just rows and columns. But if you have a categorical variable, so I'm actually going to take type, steel and wood. Let's say I wanted to separate steel and all of my coasters in the table by whether or not they were steel or wood. So I'm going to drag those out. And so now it has sorted them. So all of the wood ones are together in the table. And then all of the steel ones are together. And one advantage to that is that now I can actually compute something. So I'm going to add a new attribute to my table. And I'm curious, thinking back to one of my previous questions about taller and faster. So I'm going to find the mean of the max height. And you might remember that, oops, I misspelled that. And I'm going to right click. So I named my variable here. And then I'm going to edit my formula. And if I don't really know the formula, I can kind of like look through the different functions. And those of you that have used Fathom, this probably looks looks kind of familiar. But I know that there is a mean function in here. Now I'm going to compute the mean of my max height. So the mean height of the wood is 81.96, while the mean height of the steel is 75.77. That might initially sound kind of surprising. So if I separate, there's my mean height, max height. I'm going to put those two values there. There's the 82. There's the 76. But look at the variability with the steel. And we have lots of steel coasters that just aren't very tall. So we can say something about the consistency of coasters that are made of wood versus those that are made of steel. One, we tend to be a little bit more consistent in the coaster design, at least related to max height, with our wood coasters. All right, I'm going to turn it back to Greg. Greg, do you want to, I know you've been following the Jamboard. Do you want to tell us some things that, or have somebody share, some folks share what they found?
Here, let me share my screen real quick.
Okay, let me stop sharing.
Awesome. So I hope that you guys kind of thought about just like how is this fun? How is it interesting? How can I use this in my classroom? I really liked a question that someone posed on this page. A great question that you can ask just to engage your students at the start is, this graph is interesting to me because, and that's just a great way to get kids engaged in just like stating why they think this is cool, why they think it's interesting. It can really get some of the kids who may not know math to talk about why do they think this is really cool. So I think Code Up is a great way to kind of introduce that low, what is it, the low entry, high ceiling kind of tasks. Because you may have some students that can, create a graph like this scatter plot right here and talk about it. But then you also have kids that just think it's fun and just like, oh, cool, look, like the top speed's higher. And then in a stat class, or in any kind of, statistics, whatever, you can have them engage like, oh, do you think that, the difference between these top speeds on the left graph, is that enough to say that the wooden coasters are faster than steel? Doesn't that seem a little like not intuitive to you guys? And you can like discuss some of that, which is pretty fun. So yeah, one thing that I do want to show you guys real quick is that there's a great way that you can kind of do like a little formative assessment piece with this. If you go to the menu button, you can share, right? So after your students, if you want to give a student or your class the data set or graph that you want them to look at, say that, drop in duration is my scatter plot, then you can go get a link and then copy this. And I use Remind 101 in my course. And so I just copy paste that right into Remind, and every single student has it available to them, hopefully on the laptop, because I don't think this works with your phones. So they would just have to have Remind pulled up on their laptop and boom, they have the document. Or you can just share it in a Google Doc, or just drop it in your Zoom or Google Hangout chat. So that's pretty cool. And I think that's about all I wanted to show you guys. Does anybody else have any more questions?
I want to quickly just add to what Greg had said.
Yeah.
So for example, suppose that you've been working on this data set, and what you want to do is actually save a copy of it. So you did some work on it. Maybe you made the data table look a certain way, or you created certain graphs. If you go up to that menu you can save the document. So everything doesn't have to live in the cloud, all right? You can save this document locally to your computer or into Google Drive. And that way you could change the title of it at once. Then you would always be able to load that file back up. If you ever have a document that has, whatever title dot CodeApp, once you have CodeApp loaded in a new browser, then you can just drag a CodeApp file and plop it into CodeApp, and that data file will open. The same thing with the CSV file. If you have a CSV file, all you have to do is drag that CSV file. Greg, do you happen to have?
I do. Would you want me to share my screen real quick?
Yeah.
I've
Emily,
been looking for data for our project. And so I happen to have, it's not a good data file per se. But
that's okay.
I am going to share my whole screen. So I know it probably looks a little small, but I am going to go to CodeApp and I'm going to press try CodeApp. And I'm just going to create a new document. And then you'll see over here on the side, I have a random CSV file and I just drag and drop. It's, I think, data.
And by random, she
like,
doesn't really mean random.
well, that's absolutely true. It is a file that I found on the internet that I'm not sure it has any true purpose for me, but it was off of, I think, one of the health databases. And I was trying to find data for a project we're doing. And so you just pull it off the site, pull it from a downloaded CSV file, you drop it right in, it pops up beautifully.
Yeah. So
Real
I don't
quick,
know
just to answer a question in the chat. It says, how could I use this for middle school students without them feeling overwhelmed? I hope that what we just showed you actually is a way that you can do that.
And we've probably linked to some videos, Greg, right? That
Yeah.
shows that, right?
Yeah.
We have a video.
Sorry,
of a
I just
7th
wanted
grade
to
classroom.
point out that those videos are in there. And just to say that we've done this with middle school kids in the second week of school, and they've been able to.
Yeah. With the middle school kids, we started out with a data set of about 35 cases and 6 variables to get them kind of comfortable with it. And then we got them into a bigger data set with many, many variables. And there's a video of me leading a whole class discussion where the kids are actually sharing their work. And it was like one of those moments where it just was beautiful. If you've worked with any of the Smith and Stein 5 practices in orchestrating mathematical discussions, I was able to really watch what the kids did and sequence their work because they were all working with the same variables. They chose the variables and I saw what they were doing and I was able to actually sequence their work in a way that built up the statistical sophistication conversation. So.
Holly Lynn, there's also a question in the chat it's asking about sampling and measures and that they're trying to replicate some things from Fathom. I can read the whole thing if you want to answer it. Can you cover sampling and measures? I use these in Fathom, but I couldn't replicate the same things in CodeApp when I played with it, preferably with data that you drop in from a CSV file. If too long of a please point me in the right direction for information to help with that.
Yeah. So yes, CodeUp does not do everything that Fathom does. So for example, those of you that have used Fathom, it had a very nice summary table feature where you could compute lots of different statistical measures. Where you have to compute statistical measures in CodeApp is actually in the table by dragging different variables into that hierarchy format and then using that part of the table to compute the different measures that you want. So that really brief demo that I did of computing the mean of the max heights for steel and wood is one way that you can compute measures. The issue of sampling, there is a sampler plugin, and we actually designed the sampler plugin. It was built off inspired by the sampler that was in Tinkerplots rather than the way that Fathom actually did it. We don't have time to really kind of go into that, but in our handout, Emily, could you just share a picture of the handout real quick?
Yeah.
In there's a link to CodeApp tutorials and video. There's a playlist. So that link, CodeApp tutorials, introduction to using CodeApp. We have a playlist where we have recorded several different demo videos on how to do things in CodeApp.
So I'm just making sure we also covered anything else that we mentioned. I think all of
we
these
mentioned the
different
videos.
things.
So we've linked for you. We've got actually lots of different videos that we've used in different. We do a lot of online professional learning, which we're going to end with today. But we go out in classrooms and work with students and work with teachers, and loves just seeing the amazing things that they do with data when they're given the opportunity. I'm actually in a project right now out in California, working in science classrooms. I'm actually not in the science classrooms. Some of my colleagues at Berkeley are, but these middle school kids in science classrooms are doing really cool things in CodeApp and learning science content through data.
And real quick, Holly Lynn, do you just want to finish out?
I think so. Thank you for continuing to share. So as I just mentioned, we do a lot in building online professional learning for about since 2015. Some of your names look familiar to me, and I've interacted with you in my courses at the Friday Institute, and since 2016, GMA has been heavily involved in that. We had 2 MOOCs for educators, teaching statistics through data investigations and teaching statistics through inferential reasoning. Those courses ran several times throughout that time span, and they've been kind of dormant for about 1.5 years. What we have decided to do was to combine them together and put them in an on-demand format. And so we're about 2 months out probably from those being live. Once they're live, then you can always have access to it. And then we have another project called Instep that is building from what we've learned from our MOOCs and actually trying to design more personalized professional learning for teachers. All of you on this call had different entry points. You've used different tools before. You've had experiences. You're at different parts of your journey as far as thinking about teaching statistics and teaching data concepts with your students. And so we want a platform, and we're working with our colleagues at RTI International to build a way for you to personalize your professional learning so that you can go in and find things that are relevant to you to meet your needs where you are. On April 15th, we're going to be doing another K-12 stat chat where we'll talk about some of these professional learning opportunities and tell you a little bit about some of some of the resources that we put in these courses. And Jima and I are going to be leading that.
Just our contact information and just quick acknowledgements to people who have funded us, such as MSF and the Hewlett Foundation.
So Holly,
yeah, go ahead.
Thank you so much. Is there any other last minute questions anyone has? And Holly Lynn, I promise by April 15th, I'll have breakout rooms set up correctly.
We might have to have a private session and teach you how to set those up.
I think they're set up. I think what I've learned is today, you have to set them up when you schedule the meeting.
Yeah.
And that's the problem. And I thought it was on my default, but it was not.
Yeah.
So I guess I'm experiencing what happens in the classroom, right?
That's exactly right. As educators, if we're nothing else, we are flexible, right? We are compassionate, we are understanding, and we are flexible.
That's exactly right.
And I just want to give a shout out to the ASA. They have spent better part of 2 decades really putting together a lot of really good materials to help support statistics teachers and they often go unnoticed and unused. So please, please, please check out the ASA K-12 statistics education resources. The online journal, statisticsteacher.org, fantastic. They have such a good partnership with NCTM, and I appreciate all the work that you all do to help support teachers across the country.
Well, thank you, Holly Lynn, and all your wonderful team members. Holly Lynn has done so much for ASA and for NCTM, and we're really looking forward to all of you being back on April the 15th. And I should mention that the next chat is going to be March 25th, and I'll be sending more details soon. So just mark that on your calendar as a K through 12 chat day. And then we'll see Holly Lynn and her team back in April 15th. So thank you again. And we'll plan on signing off.
All right.
Thank you.
Thank you.
Please contact us if you have any questions.
Absolutely.